Hello everyone. We're going to go over this question. Question 4. C is a point on the x-axis. A and B coordinates are given and they are vertices of a triangle. AB intersects the x-axis at E. So that's something that needs to be unpacked. At E, we already know one value of the coordinate, which is the y value. So we know at E that y is equal to 0. We just don't know x, so I'll just make it x. Angle ABC is theta, so you know that that theta is not an angle of inclination. And then BEC equals to alpha. Alpha is an angle of inclination because it is measured anti-clockwise from the x-axis. That's what makes it an angle of inclination, and that's what makes theta to be not an angle of inclination. Calculate the gradient of AB. Evidently, we have the coordinates of both A and B. Let's label these coordinates and write down the gradient formula. Now let's substitute and calculate. There you go, the gradient of AB. Question 4.2. Determine the coordinates of E. Alright, so for E, we have already noted that the y value is 0. We just need to figure out the x value. But there's also something interesting about E. E is part of the straight line AB. So we know that the points A, E, and B are collinear points. This is very important because it's going to tell us what we need to do. So collinear points simply means that the gradient of the line segment from A to E equals to the gradient of the line segment from E to B is also equal to the gradient of the line segment from A to B. All we have to do is reverse engineer the gradient formula. Perhaps we can take EB, right? We know gradient of EB is also 5/3. And then if we unpack the left-hand side and write it out, we have, now let's label the point B as x2, y2 and the point E as x1, y1 and substitute. Now let's solve for x by cross multiplying. 4 minus x is a binomial, so we have to put it in brackets. Now let's distribute the bracket and isolate x. Now the question is clear. We're supposed to find the coordinates of E. We must conclude. Question 4.3. Determine the size of alpha and round off to the nearest whole number. So like we said earlier, alpha is an angle of inclination because it is measured anti-clockwise from the x-axis. And for angle of inclination, we use the formula, and the gradient that we're going to use is obviously the gradient of AB because alpha is the angle of inclination of the line AB. Fortunately, we already have that gradient. We obtained 5/3 earlier. Solving for alpha, we have arctan of 5/3, which gives us 59 degrees. The question was clear to say round off to the nearest whole number, so I've already rounded off. Next question. If theta is 76 degrees, and also we know alpha is 59, determine the equation of the line through A parallel to BC. So we need to visualize that line which passes through A and is parallel to BC. So I'll try my best here. It could be a line that looks something like this. There we go. There's our line parallel to BC. That's what's guiding me. So these two lines are parallel, and we know that parallel lines have equal gradients. This is important. So basically we know that the gradient of BC is equal to the gradient of this new line. We're interested in the equation of the new line. which means we need to find its gradient. But to find its gradient, we need to find the gradient of BC first. And if you check, we don't have the coordinates of C. We cannot use gradient formula to find the gradient of BC, which means we need to use angle of inclination of BC to find the gradient of BC. Let's name this angle of inclination beta. So basically we find beta first, and then we use that beta to find the gradient of BC, which will in turn become the gradient of the new line. Now, with these questions, the theorem exterior angle of a triangle equals to the sum of the opposite interior angle is almost always a reality. We know this is 59, we know that is 76. All we need to do is to find beta, and using that theorem, we are going to say beta equals to 59 plus 76 degrees exterior angle of a triangle. We're giving our reason statement plus reason. And beta is 135 degrees. Now, we know that the gradient of BC will therefore be equal to the tan of beta, which is tan of 135, and this gives us -1. So that's step 1 of finding equation of a straight line. Step 1 is always to find the gradient of the straight line in question. So now the gradient of the new line is equal to -1, since we're told that this line is parallel to BC. Step 2 towards finding equation of a straight line is to substitute into y is equal to mx plus c. And we are going to substitute this new gradient that we just got together with the coordinates of any point on the straight line. We only have one point, so we are also going to substitute A. Let's substitute and conclude. I hope you found this video helpful. Until next time, goodbye.